Hey guys, we're going to move into Unit 10. This is another one of the 8th grade units, and the title of the unit is Pythagorean Theorem and Irrational Numbers. So we're going to be talking about a lot of what are called radicals. Radicals is a term that is used anytime you use a square root or a root button. So we'll be talking about squares and square roots today. These are the first couple of pages of your new packet, and I expect that you listen along and fill in the notes as you go. If it goes too quickly, then you can pause the video. There will be times where I ask you to pause the video, do a section of the notes on your own, and then come back and check your answers. So please follow those directions. You can use a calculator, and I'll show you where some of the buttons are on the calculator that you'll need. Please use Desmos. Do not just Google. Please use Desmos calculator or a handheld calculator today. So we're going to talk about squares and square roots. We've used some of these terms already, and so we'll be putting more context behind them. This will lead us into what is known as Pythagorean theorem, and that is a rule that applies to right triangles. And it helps you find direct distance between 2 points that are not in a straight line or not at a right angle to each other. So the first thing we're going to do is called squaring a number. This is the first part of your notes. Squaring a number is raising that number to a power of 2. Square means 2. For example, 4 squared we know is 4 times 4. That is 16. And we know that the exponent tells us how many times to multiply the base. Be careful with negatives. 2 different things could happen. It depends on where the negative is and if there are parentheses. When a negative value is squared, be careful to note whether or not the negative sign is inside parentheses. Observe the difference below. So this first one is negative 2 squared, which means this is negative 2 times negative 2. That would be a positive 4. However, if you have it written with no parentheses, this means the opposite of 2 times 2. Well, 2 times 2 is 4. The opposite of that is negative 4. Negative 3 times negative 3 is going to be 9. But the opposite of 3 times 3 is negative 9. So it's not always the case that squaring a negative number creates a positive outcome. This would be positive 16. And the opposite of 4 times 4 is negative 16. So be careful with those parentheses. All right, the next section is what's called a square root. Taking the square root is the opposite of squaring a number. So we want to know what times itself equals that thing. The square root of 16 is both 4 and negative 4. We just saw where a negative 4 times itself is positive 16 because 4 times 4 is 16 and negative 4 times negative 4 is also 16. So a number can have 2 roots. The positive square root is called the principal square root. That's the one we mostly use. And when using the square root sign, the solution is the positive square root. So 99% of the time, we're going to be doing the positive square root. Additionally, 16 is called a perfect square. Because its square root is a whole number. So another example would be 9, because 9 is 3 times 3. 4 is a perfect square because 4 is 2 times 2. A non-perfect square could be like 21. 21 doesn't have a whole number that multiplies by itself to give you 21. All right, let's keep going. Oh, well, I've got this picture here. So square root on your calculator, most of you are using the TI-73s, is right here. It's above the square key, and it's in yellow, so that means you have to hit the second key first before you use the square root key. square root sometimes is called radical. So if you hear the word radical, you know that's the root key. All right, and then this next part, it won't let me get this back on the screen. Here we go. All right, the next part we're going to be filling in the squares. I want you to do this as much as you can without the calculator. So try not to use the calculator at all. If you have to do some long multiplication to get that done, that's fine. And then I want you to list the square roots, and I'll do a couple with these. So 1 is the square root of what number? 1 times 1 is 1. 2 is the square root of what number? So 2 times 2 is 4. 3 is the square root of what number? 3 times 3 is 9. So that's how you're going to fill in that row. These two rows go together. So pause the video, fill in, and then come back and check your work. No calculators. All right, look and see how you did. You should have the same number in both rows. They're just in different spots. So 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. So another way to think about squares and square roots, if you think about a square, and if its area is 81, what are the dimensions of the length and the width? Because that's how you find area, right? Length times width. So the root, the base or the root of that square is 9, and then the other dimension is also 9. So this is the square's root, and then this is the square. So that's another way of thinking of square and square root. All right, let's head over to the next page. So calculating some squares and square roots. Remember, squaring just means multiplying by itself. Square root is what times itself gives you that number. We'll do a few together, and then you guys will go back and do some on your own. So -7 squared is just -7 times -7. That would be a positive 49 because negative times negative is a positive. Notice how the negative is in the parentheses. 2/3 squared, that's 2/3 times 2/3. So 2 times 2 is 4, 3 times 3 is 9, or 2 squared over 3 squared. This is the opposite of 9 times 9, so that's -81. Negative is not in parentheses. All right, number 4. This is the opposite of the square root of 196. So the opposite, so this is called the radical sign, and that means what number times itself is 196? We saw on the last page that is 14. So the square root of 196 is 14. We want the opposite of that, so that's -14. Square root of 81, what number times itself is 81? We know that's 9. And then the square root of 9 over 16 could also be written as the square root of 9 over the square root of 16. You'll take the square root of both. That's 3 over 4. All right, number 7. This means 2 times the square root of 64. So 2 times the square root of 64. 2 times, we know the square root of 64 is 8. So that'd have to be 16. 5 plus the square root of 121. Square root of 121 is 11. Add 5, that's 16 as well. All right, let's look at this one. This is -3 times the square root of 225. And then we're going to add 10 later. Remember, order of operations. So you can kind of think of radical or square root sign as being parentheses. You got to do that first. We can't multiply till we know what that is. That's -3 times 15 plus 10. We're going to do this part first. That's -45 plus 10. So that's -35. All right, I want you to pause. I want you to do 10, 11, and 12 and come back and check your work. Okay, for number 10, square root of 144 is 12. Square root of 36 is 6. We subtract, we end up with 6. 11 is 15 times the square root of 16. Square root of 16 is 4, times 15 would be 60. And then number 12 is the opposite of the square root of 81, so that'd be -9. Add 20 and you get 11. So we can evaluate some equations and some expressions with square roots in them. Last one, 13 and 14. A group of 225 students need to be arranged in a square formation for a halftime performance. How many students need to be lined up in each row? So that's an area problem. We've got 225. They make a square. So to figure out how many students in each row, I guess rows would be over here. That's the square root of 225, excuse me. And we know that that's 15 students per row. Number 14, Ivan's room is a square with an area of 144 square feet. What is the perimeter? So we need to know all of these dimensions. Well, square root of 144 is 12. So each wall is 12, and there's 4 of them for perimeter. So that's 48, and that would be feet. All right, I want you to summarize. I want you to tell me what a square is, or squaring a number. And then I want you to tell me what a square root is. Pause and write out an explanation for both of those. For squaring, you should have had multiplying a number by itself. And for square root, finding a number when squared equals the number in radical sign. All right, let's do a little bit more. I want you on page number 3, I want you to answer these problems. You're going to pause the video, answer all of page 3 on your own, and then come back and check your answers. These are just exact problems just like we just did. So pause and answer. All right, for number 1, C was the correct answer. D was close, but they used the word even instead of whole. Number 2, the only one that is not a perfect square is 200. Answer for 9 is 3, square of 4 is 2, and 64 is 8. If you take the square root of 200, you get, what do you get? Like 14.142, something like that. All right, for 3, D was the only one less than 0. Less than 0 means negative, so that would have been the only answer that was negative. Number 4, some kind of explanation to show that one of them ends up positive and one ends up negative. And then for number 5, you should have gotten 90, 81, and 9. For number 6, that would have been 196 minus 12 is 184. Number 7, 25 over 36. A decimal answer here is not okay. We were given a fraction. We need to end with a fraction. 3 times 12 is 36. Number 9, 25 plus 7 over 8. Leave it as a fraction. 10 was 15 plus 13, and that's 28. And then number 11, square root of 400 is 20. And number 12, we're doing perimeter, so the square root of 169 is 13. There's 4 sides, so 52. All right, last page. So we've talked about perfect squares. We take the square root, we get a whole number, and they gave us 25 as an example. You can read through the example. Let's do some perfect squares of 16. Those are 4 and negative 4, because 4 squared and negative 4 squared equals 16. 81 is 9 and negative 9, because 9 squared and negative 9 squared are 81. You keep the pattern going and pause to check your work. or pause to finish.